Hi everyone, myself Dhanasekaran, Department of VC, Assistant Professor, K.S.Rangasamy College of Technology. Today we are going to see multiplexer and demultiplexer in this video. First, the outline of this video is first introduction, digital logic gate simple, multiplexer, black diagram of multiplexer, logic simple of multiplexer, logic diagram of multiplexer, truth table, demultiplexer, and black diagram of demultiplexer, logic symbol of demultiplexer, logic diagram of demultiplexer, truth table, and lastly we are going to see application. Let's see what is multiplexer and demultiplexer. So before we going to see multiplexer and demultiplexer, we should know about logic gates. So these are the logic gates, that is NOT, AND, OR, XOR, NAND, NOR, and XNOR. So these gates are used in the multiplexer. And multiplexer we can call it as a selector, data selector, and demultiplexer we can call it as a data distributor. So the term multiplexer means many into one. So we can select the number of inputs and the output only we can get only a single output. That is a multiplexer. That is many to one. The multiplexing is the process of transmitting a large number of information over a single line. So we can transfer a large number of information in a single line. So we can select the different number of inputs. From different number of inputs we can select only one output. So that is a multiplexer. And the digital multiplexer is one of the combinational circuit. Okay, so that select the one digital information from several sources and transfer the selected information on a single output line. So let's see what is the truth table and what are the circuit diagrams multiplexer we have. Okay, so multiplexer also called as a data selector, as I told you earlier, right? The multiplexer has several data input line and single output line. So please note the word single output line. So multiplexer directs one of the inputs to the output. So we have different inputs in the multiplexer input side. So we can select only one output. So that is the function of multiplexer. So that is 1 to, so many to 1, that is a multiplexer. Okay, so multiplexer contains the following. So data inputs, we have selection inputs, and we have a single output. So selection input determines the input that should be connected to the output. So without the selection input, we cannot select the input, whatever the input we going to give. So we going to select the particular input to the output. So that is the input we going to connect to the output is we going to select through the selection input. Okay. The multiplexer act like a electronic switch. Okay. So it is one of the electronic switch. It is a combinational circuit. Okay. So this is the black diagram of multiplexer. So we have 4 inputs, that is input 0, input 1, input 2, and input 3. And selection pins we have S1 and S0. And output is it shows the output. Okay. So if you want to select the 0 output, so you have to give a selection lines, that is S0 and S1. For example, S0 is 0 and S1 is 0 means we can get the output whatever we going to give the input 0. Okay, so that signal we can get in the output. So that is the multiplexer function. So this is the 4 to 1 multiplexer logic simple. So here as I told you earlier, select inputs is there and data inputs is there. So select inputs, that is the selection line S1 and S0, data inputs D0, D1, D2. This is one of 4 to 1 multiplexer, and the output is Y, that is the data output. This is the logic diagram. So here if you see 3 different logic gates we used. One is NOT gate, and another one is AND gate and the OR gate. So 3 different gates we used in the multiplexer. So input lines are here we take a C0, C1, C2, C3. We can take it also T or A, B, like that. We can take anything. Okay. So here I take C0, C1, C2, C3. Okay. The output is Y. Here, please note that, and the first gate, that is the first AND gate, will be connected with the C0, and that is also connected with the selection pin S0 and S1. If it is a S0 is 0 means only we can get the C0 output in the Y. Otherwise we can Not like that. Also in the S1, we if it is an S0 1 and S1 also 1, we can connect the C3 input through the Y. Okay. So as discussed in the truth table, we can see it. Yeah. The S1, S0 and the output of Y. So first, if you give a selection lines 0, 0, you can get D0 output. So I will show in the diagram. See, here if you give a selection lines 0, 0, your output will be the D0. Okay. Here the demonstrate the operation of the circuit. Consider the first case, that is S1 and S0 is 0. So what will be the output? The output will be D0. So whatever you giving in the D0, that will be you can get the output of that is input of D0, you can get in the output. Okay. So the next one, otherwise other gates are, that is the first input system. We can get the other AND gate also, others are 0 except that first AND gate. Okay. So next one, the S1, S0 is equal to 0, 1, the binary 1, that is called, it is applied into the selection line. So we can select the D1. So whatever the input you give into the D1, it will get into the output Y1. Okay. So the next selection line is 1, 0. So if you give 1, 0 in the selection line, so the D3, that is D2 will be activated. So what will happen? Whatever input you giving to the D2, that will be connected to the output Y. Okay. So the last one, as like the last one, S1 and S0 is selection input of 1, 1 means the output of Y is equal to D3. So D3 obviously it's activated when you giving the selection line S1 and S0. Okay. So in general 2 power n 2 1 multiplexer, that is 2 power n to 1 multiplexer, that is 2 to 1 marks, 4 to 1 marks, 8 to 1 marks, 16 to 1 marks, 30 to 1 marks. There are multiple multiplexer available in the. So this is the truth table as we discussed. Okay. So again I tell you, 0, 0 means you can get a D0 output, 0, 1 means you can get D1 output, 1, 0 means you can get D2 output, 1, 1 means you can get D0 output. So as I said earlier, the multiplexer is a data selector. You can select the data, whatever the inputs, that is D0, D1, D2, these are the multiple inputs. You can get the only one output in the Y side. Okay. So that is whatever you giving into the input, that is D0, D1, we can select whether you want D0 or whether we want D1 or D2 or D3. Okay. So this is a 8 to 1 multiplexer. Okay. So here we have 8 AND gate is there and 1 OR gate, and as usual 3 NOT gate is there. So we can connect the 8 0 to D7, that is a 8 input is there and only 1 output. So that it's called the 8 to 1 multiplexer. Next we are going to see demultiplexer. As I said, multiplexer is a data selector, demultiplexer is a data distributor. However, multiplexer selects the data, but demultiplexer it distributes the data. That is the 1 to many. So multiplexer is 1 to, so many to 1, but the demultiplexer is 1 to many. So demultiplexer is a combination logic circuit that performs the reverse operation of multiplexer. Demultiplexer means 1 to many. So demultiplexer is a circuit with 1 input and many output. By applying a control signal, we can steer any input to the output. Okay. So few types of demultiplexer, 1 to 2, 1 to 4, 1 to 8 and 1 to 6. These are the demultiplexer. Okay. And the demultiplexer is the process of taking information from one input and transmitting the same over the over of several outputs. So we have we can take only one input and we can distribute as several outputs. So this is the black diagram of demultiplexer. Here we have only one input, whereas in the multiplexer we have different inputs. But here only one input, and we have the different 4 outputs here. And as usual, we have a selection lines, that is S1 and S0. So by selection is also called as a control signal. We can select the output, that is by using this selection lines. That I can show you the truth table. You can easily understand. Okay. So this is a logic symbol of 1 to 4 demultiplexer. It's the same like as a multiplexer, but it's a different is output and input. Okay. So here the selection lines is 1 and the S1 and S0, and the data output is D. Here the output is Y0, Y1, Y2, Y3. Whereas in a multiplexer we have 4 inputs, only 1 outputs. Here in the demultiplexer we have only 1 input and 4 outputs. The outputs are Y0, Y1, Y2 and Y3. Okay. So this is the demultiplexer logic diagram, and we have a selection lines S1 and S2, and D is the data line, and we have outputs D0, Y1 and Y2 and Y3. Okay. So this is the truth table, and D is the data input whatever we are going to give, and select input is S1 and S0 is the selection lines 00 and 01, 10, 11. Output is Y3, Y2. We have a different output. We can get only one output at the time, because when you select the select lines, that is S1 and S0, if it is in S0, S1 is 0 and S0 is 0 means you can get only Y0 output. So in that Y0 we can get the data. Okay. So if it is in S1 is 0 and S0 is 1 means you can get the Y1 output only. So others output will not, you can get the other input or output. Okay. And the next one is the selection line is S1 is 1 and S0 is 0. You can get only the Y2 output. Okay. So other Y3, Y1, Y0 is 0. Okay. So whereas in S1 1 and S0 is 1 means you can get Y3 output. See the difference, multiplexer and demultiplexer. So multiplexer is many to one, and demultiplexer is the single one to many. That is the difference. Okay. Next we are going to see the application. So why multiplexer used? Okay. Multiplexer used to reduce the number of connecting wires. That is here you can see the application of multiplexer is the communication system and the computer memory. In communication system, the communication system where it is used, that is a transmission system relay. So as I already told that it is used as an electronic switch multiplexer. Okay. So it is used in a relay and tributary station and the communication network. The efficiency of the communication system can be increased and considerably using multiplexer. So while using a multiplexer we can increase the efficiency of the communication system, and the multiplexer allows the process of transmitting different types of data such as audio, video, and same time using the single transmission. So we can transmit the single transmission whenever you want to video or audio, you can use the single transmission like that. And the next application of multiplexer is the computer memory. So in computer memory, the multiplexer used in computer memory to keep up the vast amount of memory in the computers, and also to decrease the number of copper links. So in the computer, we need to connect the different connectors. So while using this multiplexer, we can reduce the multiple number of connections. Okay. So next one is application of demultiplexer. And it is demultiplexer also used in the communication system. The communication system uses the multiplexer to carry the multiple data, like as we discussed in the multiplexer also. Audio, video, and other form of data using a single line for transmission. This process make the transmission easier, and the multiplexer receives the output signal of multiplexer and converts them back to the original form of data at the receiving end. As you said, the multiplexer is a one to many. Okay, we can connect the many number of outputs with a single output input. Okay, and the multiplexer and demultiplexer work together to carry the process of transmission and reception of data in the communication. As I already said, that it is used in the communication system and computer memory. So most widely used in the communication system. Thank you all.